Well, good morning, good afternoon, or good evening to everyone, depending upon where you're joining us from. I want to take this opportunity to thank everyone for joining us today in our final horticulture webinar Wednesday, titled Moving Projects Forward, Leveraging Incentives to Minimize Costs. For those that have attended the previous webinars, thank you for staying with us, and for those joining for the first time, welcome. Outreach and collaboration with stakeholders is one of the DLC's main values and central to our work. As such, the DLC had planned on having an in-person horticulture summit this year, but unfortunately due to COVID, we had to transition to this virtual format. So hopefully it works for everybody. So just as a reminder, our primary goals of the webinar series have been to increase awareness of the DLC's horticultural lighting technical requirements and qualified products list, and also to help accelerate the adoption and acceptance of utility rebate programs to support energy savings for indoor grow projects. To those points, we will spend the next 70 minutes on today's webinar. And for those that signed up, we will follow that up with an additional 40-minute breakout session, allowing you to ask the expert additional questions. During the presentation, please feel free to use the chat box to pose questions. General questions will be addressed by DLC personnel. Questions specific to one of the panelists will be read aloud during the main session Q&A period, which is the last 30 minutes, as you can see on the agenda. Also, I just want to advise everyone that today's webinar will be recorded and posted shortly on the DLC website. My name is Stuart Brzezinski, and I am the Technical Director here at the DLC and also serving as the moderator for today's webinar. For today's session, we have three primary learning objectives. First is to understand how to maximize incentives with horticultural lighting applications. The second is to see examples on how to leverage energy savings resulting in maximized utility incentives. And the third being to learn a few things from utility early adopters on incentive structure. So let me take this opportunity to introduce our panelists for today. Between the four of them, they will provide you great information aligned with the learning objectives I just mentioned. Jeannie Sikora is an energy engineer with ClearResult. Among other things, on behalf of utility companies, ClearResult develops and implements utility incentive programs. Mike Zortarian is an electrical and horticultural design engineer with his own company, Zortarian Engineering. Brady Nemeth is the utility rebate coordinator with Fluence, a luminaire manufacturer. And Bob Gunn is the founder and CEO of Synergy, who works with utilities and growers in order to maximize energy savings through the use of incentives. So today, our first presenter will be Jeannie. So we'll let Jeannie go from here. Thanks.
Thank you, Stuart. Just real quick introduction. I'm a senior engineer with ClearResult. We're a utility energy efficiency program implementer with headquarters in Austin, Texas, and offices all over North America. I'm part of our national core engineering team, and in that role, I work on utility program design and serve as a subject matter expert for agriculture. I'm not a farmer. The first time I was in a barn was after I got my master's degree in agricultural engineering. But I've worked in agriculture over the course of my career, and in my current role at ClearResult, I have the opportunity to specialize in energy efficiency for the agricultural sector, and most recently with a focus on indoor ag. Next slide, please. So I like this quote because I think it sets the groundwork for why this discussion is important. Crops are moving indoors for many reasons. In a controlled environment, growers can produce crops year-round. They can have consistent and predictable yields, and they can do this with enhanced security, biosecurity, and reduced inputs such as water, fertilizer, pesticides, and herbicides. Next slide. So real quickly, I'm just going to review plant growth. It's a very oversimplified diagram of a very complex process of photosynthesis. So plants take in light in the photosynthetically active radiation, or PAR spectrum, along with carbon dioxide, which they can get from the atmosphere or which may be purchased or generated on site, and water to generate biomass and oxygen. Many plants are like Goldilocks, and they need their conditions to be just right for optimum growth. So they need the correct temperature, they need the ability to drive moisture up through the roots and out through the leaves, and they need the correct mix of nutrients. In general, the more carbon dioxide and light that you input, as long as other factors are adequate, the more a plant is going to grow. There are limiting factors, and each plant's response is going to be different. For example, lettuce, if you give it too much light, it can get leaf tip burn. But with cannabis and tomatoes in general, the more is the better. Next slide, please. So I believe we have an audience that may be differently versed in horticultural lighting. So I just wanted to introduce a few terms so we don't lose anybody. We've got a great panel coming up, and I want to make sure no one gets distracted by acronyms and terminology that might be thrown around later. I won't talk through the entire table, but I do find this to be a handy reference when discussing horticultural lighting. So as I mentioned in the previous slide, plants need a certain amount of PAR radiation. That's similar to the amount of visible light people need to see. So there are two components of light plants need to grow. One is that intensity of that light, which is expressed in ppfd, or photosynthetic photon flux density, and which aligns with foot candles that we use to express the intensity of light in a visible source. And the other is photoperiod, or the duration of light. So daily light integral is the cumulative amount of energy that the crop receives over the course of a day. And it's equal to the intensity of the light, the ppfd, over the photoperiod. And different crops need different amounts of ppfd and DLI. For lettuce, we know that they like about 17 DLI and about 200 ppfd. And you go over that and you might get that leaf tip burn. For cannabis, we're not yet sure what the optimum DLI is for growth because we can't really get that amount of light intensity into a controlled environment feasibly. Next slide. So stepping back again, I'm going to give a brief overview of utility incentives. These incentives are designed to benefit the public. So each state or province, and sometimes municipalities, will mandate that public utilities collect funds from their ratepayers and design incentive programs to encourage investments in energy efficiency or reduction in power demand. These programs are designed to incentivize efficiency improvements in order to offset the future needs to build new power plants. Some utilities might operate their own programs, but many utilities prefer to contract the operation of those programs to companies like ClearResult, because we specialize in running those programs. And because these are mandated programs, there's oversight from program evaluators, and they're there to protect the ratepayers' interests. So these energy savings goals are being met. So the design of programs varies greatly because the rules are set by the State Public Utility Commission usually, and then further by each utility with how they want to structure incentives to meet the required energy savings goals. So incentives can be calculated using a prescriptive methodology outlined in the savings source of record, which is most states have their own technical reference manual, or TRM, that stipulate how to calculate savings for these programs. I kind of refer to them as a cookbook for these programs, for how we get savings. For efficiency improvements that don't fall within these cookbooks, most programs offer custom incentives for which savings need to be measured and verified. For the most part, incentives can take the form of a point of sale discount, like when you go to Home Depot to buy an LED light bulb and there's an instant rebate, you get $1 off of that light bulb. Or they can be rebates that you need to apply for. And just to make another point to help set the stage, these programs have been around for many, many years and have historically focused on pushing the market toward LED lighting, thanks in large part to DLC and those types of organizations. They've been very successful, and many programs often got the majority of their lighting gains, their efficiency gains and goals from lighting projects. But these lighting intensive programs are often supported by a trade ally network, and these trade allies specialize in handling rebates for customers doing lighting retrofits. Next slide, please. So utility incentives for horticultural lighting, what's the problem? Well, due in large part to this historic focus on lighting and a widespread lack of understanding of the difference between horticultural lighting and visible lighting, as well as these patchwork of programs and program implementers, there's just been a serious lack of standardization for how incentives are treated for horticultural lighting. Many utilities are just now starting to understand the market and gather the information that's needed to figure out what the savings are for efficient horticultural lighting. For example, what's the baseline when you have a new construction facility? For visible light, we have lumen power density metrics that are in the codes. and we can take our baselines from those lumen power density numbers. For horticultural lighting, we don't have LPD because it doesn't make sense because we don't need lumens. And unfortunately, there is some legislation in some jurisdictions out there that do mandate LPD for horticultural lighting. It sets boundaries that don't allow cannabis and hemp growers that flexibility in the processes, and generally can thwart innovation for growing this crop. And some of our other panelists might touch on that a little bit later. But because horticultural lighting doesn't fit into standard or prescriptive programs where we just need that cookbook approach, custom projects, we have custom projects, and these can put a little bit more burden on the customer for a number of things. They have to provide data for measurement and verification. We need sometimes they need to allow us to get in their site to install data logging equipment. We might need to get on site to participate in walkthroughs with program engineers, and they may need to respond to multiple questions about facility operation, among other tasks. So, and because there's very few established trade ally networks that focus on helping customers obtain custom utility incentives, the onus has been on the customer to know what rebates exist and to navigate the rebate process. So fortunately, we're starting to overcome this obstacle, and you'll hear from other panel members who are helping to break down those barriers. But in general, these have been stumbling blocks for customers with horticultural lighting. Next slide, please. So I'll take a couple slides to tell you about how my company is working towards standardization and facilitating incentives for indoor growers. In my region, we were working with a utility that, due to recent cannabis legislation, had a number of growers moving into their territory. And the utility was struggling with how to handle these incentives for growers, and they were motivated to standardize the approach to reduce the burden on the customer while using those program administration dollars wisely. So in partnership with that utility and its program evaluator, we agreed upon the conventional technologies that would be used in new construction facilities. And then from those baselines, we calculate energy savings. This approach allows us to help quickly pre-approve projects, so we're not impacting construction schedules while customers wait for pre-approval. And by normalizing for light intensity, we're taking the grower's operational preferences out of the equation, and growers aren't bound by a metric such as lumen power density that doesn't make sense for their operations. So now ClearResult has a written methodology that we can use to proactively engage program evaluators around the country. So we have an agreed upon approach for calculating incentives for new construction horticultural lighting projects. Next slide, please. And just a little more detail on our methodology. It's currently limited to new construction cannabis operations, but we've adapted it to meet some needs of growers that are expanding operations, maybe increasing PPFD levels in existing grow rooms and growing crops other than cannabis. The methodology establishes default values such as input wattage and efficacy of common lighting technologies, establishes baseline technologies by growth stage, and sets default values for PPFD, photoperiod, and DLI that can be used when grower supplied values aren't available. And in the future, we're hoping to expand this to add other common indoor crops, and we'll be refining the methodology for greenhouses as well. Next slide. So just to summarize, there are a number of ways to treat horticultural lighting projects that don't fall into standard lighting programs. We can follow the typical custom approach and measure and verify savings, putting the burden, a burden on the customer in general. We can assume a one-to-one replacement and use documented hours of operation. We can treat horticultural lighting similarly to standard lighting by offering those point of sale discounts at the distributor, where we make a lot of assumptions and provide an instant rebate based on the savings that we've assumed. And there's a recent draft of a protocol for Michigan that takes this tack. So we believe that our current approach helps maximize incentives and offering significant benefits to the utilities that need to meet their savings goals and to ratepayers to get the accurate savings. And so we feel that we're improving the accuracy of energy savings at the same time as reducing the burden on utility customers. Next slide. So with that, I will conclude, and I'd like to pass it over to our next panelist, Mike Zartarian.
Hey everyone, good afternoon, morning, or evening. Mike Zartarian from Zartarian Engineering. We have a I guess, a unique market niche in this industry where we are both engineers and growers. So we're in and out of these spaces on a regular basis. And next slide. And give you some context of what our perspective. You know, we think of ourselves as growers first. So we design new facilities, and especially in cannabis, maximizing the effectiveness of the facility and the square footage that you're licensed is really important. So we've gotten into designing these facilities, new construction and retrofits and upgrades. We also commission these spaces as well. So from an agricultural point of view, like making sure that they're going to handle that load of with all those plants in the room. We also do LED fixture, sensor, and other cultivation equipment design, one required and one necessary. Next slide. So I wanted to go over sort of the different sectors of indoor ag. We work both pretty fluidly between commercial ag, which is food crops, which is mostly lettuce when you're talking about indoor right now. Some, especially in the United States, some tomatoes and other vine crops are grown, and more crops are grown, in international markets more commonly. But so when I say com ag, I mean vegetables. But for the most part, cannabis is what's bringing us to this conversation today, and the primary market is indoor cannabis. So top left there is, so it's sole source, so it's only artificially lit inside a warehouse like this picture here. And it is where the most light is used by far. So we're using 50 electrical watts per square foot in these spaces, or more. We would like more. We always want more. We pretty much nearly always want more light in these situations. So then indoor com ag, I don't have an arrow between indoor com ag and indoor cannabis, because even though they're doing similar things, I think it's important for folks on, in the supply chain to understand that there's not a lot of commonality between these two. They don't talk to each other very much. So what works in one sector will almost certainly not work in the other from, for standards. It's just different. And then greenhouse cannabis and greenhouse com ag actually have more in common, just because the structures are similar. But there aren't as many greenhouse ops for cannabis, especially in the Northeast. There are more of them in hotter, more arid, high sun environments. And then your greenhouse com ag is sort of the most common model internationally, especially in called the Dutch model or Dutch greenhouse in Holland. They have a lot of these types of greenhouses where it's mostly natural light with supplemental. Next slide. Just an illustration for general lighting, folks. As I said, we use a lot of light growing cannabis. So inside the flowering stage for cannabis, our average eye is about 1,000 par or 65,000 lux. So very bright. And I have down here as a reference, we have 750 to 1,200 lux in a highly lit professional laboratory. Next slide. And in calls and in our panel call for preparing for this, as well as other industry calls, it's been people put forward the idea of talking about light energy as a process input, and I could not agree with that more, because really it's an energy input into growing the plant, and especially in cannabis, if you change that plant-specific blend of photons, as if you change the lighting technology from HPS to LED, you have to make adjustments to all of the other, how you grow. It's a total change to your process, and that is sort of why a lot of the industry is actually kind of resistant to changing. Next slide. And the reason is that so much that standard process has been developed under HPS lighting for the last, I'd say, 30 years and 150 cannabis lifetimes. So all these nutrient programs have been developed under it. The most popular strains and cultivars have been developed under HPS. This is what people are comfortable with. This is how most cultivators have cut their teeth and where they've honed their intuition. So again, in a world where people are paid by how much they produce, the people on the ground, the cultivators are not always very gung-ho to switch over. There's still a lot of feeling in the industry that LEDs have not gotten there yet. They're not able to grow the same quality crop. I totally disagree with that, but that is a prevailing notion in the industry still. And last slide. And in context of working with cannabis cultivation folks, I just wanted to give a little bit more context as to what pressures these folks feel on a day-to-day basis. So yield is yield is how the growers, maybe not necessarily owners, but the growers are paid. So they're really sensitive to a process change, switching the lighting, which is going to affect their ability to hit their numbers. And the owners of these facilities sometimes have not owned a large facility or building like this before. So they're just new in general to the process of working with all these different groups, constructing or retrofitting this large building. There's so much coming at them, especially during construction phase of licensing. This is an extremely heavily regulated industry, so they have a lot going on, and they don't have a lot of moments in their day to deal with rebates. Like, they definitely need to be reminded, because even though for a lot of them it's a significant amount of money, it just doesn't make it onto their radar, because it's something that usually happens. They want to have happen later. Like, can't we just do this later in the process? When most of us on this side are trying to start that early. And the cannabis market is volatile, very volatile. The prices vary from state to state by 100%. At any given time, like, for example, I'm in Massachusetts. We had during COVID, our recreational market was shut down for the better part of 2 months. So these folks, they don't have a stable business environment. I mean, still federally legal. So one thing is that the payback period that a business in this sector is going to accept is much shorter than standard industry. So especially it's starting to get longer this year, but anything more than 3 years is a tough conversation to have with a cultivation owner. They have so many things they need to pay back right away. That they're much more interested in getting up and operational for a lower amount of capital than investing now for the future. In many cases, in many markets, because the downtime for a retrofit, if you're upgrading, it's incredibly expensive. These crops are so valuable, hundreds of dollars for each individual plant. And as I mentioned before, and is worth mentioning again, there's a lot of regulatory overhead, and a cohort of people a lot of them have not dealt with any of these regulations before. And I'm talking not only about, regulations around lighting and rebates. I mean, everything from, in the cannabis industry, we have to tag and trace every single plant all the way through the facility. And, in a facility, a moderately sized facility, there are 10,000 plants. So there's just a lot going on for these folks. So look forward to the Q&A, and I'll hand it over to the next presenter. Thank you.
All right. Thanks, Mike. This is Bob Gunn here with Synergy. I think this is a really good transition to go from, Mike pointed out that sometimes, growers are busy. There's a lot of regulatory red tape and other things they're looking at, and they might not have the awareness or the bandwidth or the vocabulary to engage with their utility. I'm a founder of a company called Synergy based in the Northwest outside of Seattle. And since 2014, when cannabis went live in Washington, we found ourselves in a position of engaging with the cannabis industry and the growers individually, representing them to go to their utilities to ask for energy efficiency incentives to help them achieve their goals, whether it be efficient dehumidification or efficient grow lights. And most of our work has been in the grow lights, which is now all LEDs, but we did some CMH incentives back in the day. So our company is steeped in the utility energy efficiency business. That's where I personally started working in 2008. And I have been in the utility space for a while. But again, we sit on the customer side as their advocate or their agent, if you will, to make sure that they can get everything that they're eligible for. And the way that we're successful is by giving the utilities what they need in order to have confidence in the savings, like Jeannie mentioned, make sure it's evaluation ready or that it satisfies the regulatory needs. So I'd say the umbrella statement of what we do is we work with utilities representing growers. Next slide, please. I'll jump right in. In working with growers, and I should say, we've done about, I think, nearly 130 completed projects, most of them grow lights. A typical incentive for a project of ours is $80,000 to $100,000. So that we have surpassed $14 million in completed applications. And in many cases, this is money that the growers didn't know how to get or didn't know that they could get in the first place. So that's always satisfying when you can be the bearer of good news. But in working with growers, we spend a lot of time explaining things like who utilities are, why they pay incentives, how the incentives are calculated, and sometimes why are we asking things about what you would have installed or the cost of what you would have installed. And all that has to do with rules and regulations on the utility side of things. So it doesn't faze us to document baseline assumptions and interactive effects between other systems, because we've been there. We've planned utility programs, and we tend to think utilities enjoy working with us, someone who speaks their language, understand what the utilities are trying to do. But yeah, utilities have a lot of questions about, it sounds too good to be true, that you would go ask for $100,000 from a utility and they would give it to you. Like Mike mentioned, folks don't really think about their utilities that much, or they've had a relationship with the utility, but usually, oftentimes not in the sense of asking them for funds. So that's what we do, and we talk about the process of what's ahead. Next slide, please, Lonnie. So the process when we're entering into a rebate application, say for a grow light, is pretty long, and we need to set the expectation that as mentioned before, this is not lighting, and there actually is a lot of misinformation about you might need to buy your incentive and then then apply afterwards. But we use this slide often to show that the last step is when rebates are paid, and it could be up to 6 months later. So the CFO or the investors need to realize that there's a lot of steps that go that go into this. There's a gold pot at the end of the rainbow, but we want to make sure that we don't misstep or buy things before we're pre-approved. So we always start by qualifying projects to see if the customer is eligible. They're on a commercial meter, for example, and they're a licensed business, for example, and if that utility is paying incentives and how big it is. So that's qualifying. Based on the utility, there just may not be incentives available, either because they're cannabis or just because they don't pay incentives for that utility. And then project scoping is an iterative process with the vendor. They might look at different efficiency LEDs. Some are more expensive, but the incentive might be $50,000 more, so it may justify it. We do some of that. And at some point, we as a company ask the customers to commit to the process, to say there's going to be this application process. We're going to be asking you for lots of documentation, but we need you to commit to sticking with us through the end. And then, of course, we prepare all the application, submit to the utility, and 6 to 8 week approval process is kind of standard. The first couple of weeks are maybe a lot of back and forth, and then 4 weeks to review it. So enough of that. Suffice it to say, there's a lot of work that goes into it, and I can never say enough times to growers or to manufacturers selling to growers that we have to get started on pre-approval before you buy anything, before you put down a deposit. It can be tricky, but I try to belabor the importance of this pre-approval process. So let's move on from there. Bridging the gap between utilities and growers is our unique strength. I think understanding what the growers' concerns are and also understanding what the utilities are looking for helps us get projects through. Growers ask us, like I say, questions like, can I actually get this money? How much will the rebate be? How long will it take? What if I'm swapping out old lights? It's a retrofit versus new construction. What if I'm increasing the light levels in the room while I'm retrofitting? Or if I'm adding lights to a greenhouse that didn't have any before? All these use cases are pretty common, and it just takes a little specialized analysis, but we can always translate those to kilowatt hours savings or demand reduction for the utilities. And it all comes down to, kilowatt hours and dollars. So those are, translating that use case to what the utility is looking for. And who's getting up in my business? That's a little informal, but we need to have the utilities come do pre and post inspections, and they'll ask lots of questions about your light levels and are you supplementing with CO2. So sometimes growers might be a little guarded. These are their major investments, and they don't want just anyone to come in and ask questions. So I often have to explain, that the utilities are good people, and they're just trying to give you money. They just need to make sure they know what they're giving you money for. Utilities, on the other hand, are asking questions that have been addressed before. Can we claim these savings? How are we going to model those savings? How do we have confidence in what energy we're saving? And how do these facilities work? Is it really 12 hours a day, 365 days a year that the lights are on and off, or is there downtime? How long is the veg cycle? Is that credible or not? And what is the baseline? I won't beat a dead horse here, but baseline is extremely important. It's the basis against which you're comparing your efficient technology. So if that basis is a double-ended fixture, the savings will be reasonable. But if you're going from a single-ended or a fluorescent, that savings will be huge. So what you input as the baseline really has a material effect on the incentive. And the apples to apples is an expression in the utility world. And we want to make sure that we're modeling parity, that we get the same level of utility from what we're trying to explain or trying to analyze. And then how do we engage customers? I'll hit on that at the end. All right, I'll move along. I've got about 3 minutes left. So this slide is really for utilities, and I'll just breeze through it. For utilities who are new to horticulture lighting, but offer incentives, I would advise not try to not recreate the wheel. Don't create a full-blown program, but really start with pilots. If you have custom commercial, use that. If you pay based on kilowatt hours saved, let's use that and not worry about a full-blown, hopefully don't have to get regulatory blessing to start engaging with this industry who are building facilities now. And I just focus on the savings and not forcing technology on new growers. As Mike pointed out, there's a lot of other wrinkles that come with new technology. I think growers generally agree LEDs are the future, but they may not be right now for them. So yeah, beg, borrow, and steal from other utilities, and show up and talk to customers. Sorry, I'm talking fast. I'll move on to the next slide, Lonnie. So here's my energy savings methodology in 2 easy steps. It starts with modeling what the grower is proposing to put in. If it's 100 lights at 500 watts each, that's 500,000 watts. That's what you're putting in. Based on the efficiency of that fixture, we will know how much PPF, or photosynthetic photon flux, is being introduced to the room. Let's assume that they have good lighting layout and it's all going to be usable. So then you back into the baseline. And what I mean by that is you divide by the efficiency, or the photosynthetic photon flux, in a baseline fixture, whatever your input is, and that's how you arrive at your number of baseline fixtures. That's our 1-2 punch for modeling savings, and we try kind of model it on the graphic off to the right. But I start with the proposed fixtures and back into the baseline. Even in retrofits, that proves useful because LEDs are advancing so much. It's, for example, we're able to add PPFD lighting intensity levels. I think Brady will give some examples of different baseline assumptions and how it affects things. There's a question about HVAC savings, but I think we're going to come back to that. In a nutshell, anytime you reduce the wattage in a room, you're reducing the BTUs that need to be cooled for those lights, and there's air conditioning savings. It's a benefit associated with that. A quick rule of thumb is, you can use SEER values or EER values. I use 25%. That's based on a pretty efficient EER value. And I think we can talk more about that later. My last slide, please, Lonnie. Second to last slide. It's nice when utilities can set the expectations and tell us how they're calculating savings, so we're all cutting from the same cloth, from the same set of rules. And I won't go through this list, but understanding what those utilities' cost effectiveness thresholds are, what their incremental cost caps are, and qualified product requirements, of course, that's really helpful for us in setting expectations with growers on the early end. And lastly, next slide, Lonnie, is for utilities. I guess this is advice to utilities. is to show up and learn about horticulture lighting. Join marijuana business associations like our company did in 2015. Go to conferences, start to learn what the moving pieces are and the concerns and how the facilities work. There's also consultants who have worked with utilities who can help out with that. Talk to the supply chain, the suppliers of lights and HVAC equipment and other things to understand what the energy profiles are. And also on the web page, I don't see this enough. I'd like to see more dedicated horticulture specific web content on utility web pages, because lighting is such a big thing and the rules for standard commercial lighting are different. Pre-approval, for example, is not required. A lot of growers do their best to follow the rules that says buy your lights and then get the incentive, and it's just wrong. I wish horticulture lighting wasn't called lighting because then we wouldn't have those confusions. So if you can say the word cannabis horticulture lighting, we're here to help you. When utilities do that, it sets the right foot forward to have good engagement with growers. And also the growers will have other questions about rates and hookups and backup generators and health and safety and other things that utilities can be helpful in helping them navigate. So I believe that's the end of my slides. We're going to pass it off to Brady from Fluence to hear from a manufacturer and some more on energy rebates. Thank you for your time. I look forward to questions.
Awesome. Thank you, Bob. And obviously I can echo a lot of what all three people have said so far. We all have pretty similar experiences so far in the industry. So my name is Brady Nemeth. I work for Fluence Bioengineering, lighting manufacturer. And like Bob, we've done a lot of projects. We kind of do it as a value add for a customer, and as kind of everyone's noted, it's not really an easy thing. If it was, my job probably wouldn't be necessary. So if you want to hop on the next slide, I'll just real high level what I'll be talking about. Bob mentioned his method for claiming savings. Ours is very similar. I'll just talk about some of the differences there. Some of the common challenges that are unique to the CEA or controlled environment agriculture space, and then some calls to action. That way everyone, whether you're another manufacturer, an end user, being a grower, farmer, whatever, or a utility, hopefully you can walk away with some action item there. So hop on to the next slide about energy savings. So for us, it all kind of starts with the lighting design. So you're going to, again, get that target PPFD from the customer. I think everyone so far has noted the fact that it kind of starts with the customer. It's not, you can't go into the IES handbook and see, what the right PPFD level is for a given crop or anything like that. Because all growers grow differently, and as Mike mentioned earlier, they might have come from a different process, and this is really a process change. So we get the target PPFD from the customer, and we honestly, steps 2 and 3 here can kind of be interchangeable. We model both, right? We model both the legacy technology as well as the proposed solution. Oftentimes we already have the proposed solution in hand. Or I get that from our sales team. And then again, like Bob, we'll back into the legacy technology there. When possible, we always try to align with third-party figures, so that way people aren't just sort of taking our word for it. I think Jeannie in her research at Clear Result, also kind of a common paper that's used or pointed to is this paper by Dr. Bruce Bugbee back from 2014, where they had done some testing on some legacy technology. And then again, just noting some of the standard practice for cannabis down below, whether it be propagation, veg, or flower. And I left off commercial agriculture there just because it can vary quite a bit. And oftentimes you're talking about DLI. I didn't want to get things too mixed up there. So if you go to the next slide, we'll take a look at just an example of kind of a 2-tier setup that we had there, where we might just model out the entire room. Occasionally, we'll just model out a 4x4, 4x8 rack when a racking system is in use. It just saves a lot of time, and honestly, there is no real additional value you get by modeling out an entire room of racks versus a singular rack there to prove out the ratio of legacy technology to proposed. So what we have here is 40 lights per row. It's a pretty clear one-to-one with 1,000-watt double-ended HPS versus one of our LED fixtures. And so if you move on to the next slide there, again, we're matching PPFD. So in this scenario in particular, it was nominally the same, a 1 to 2% difference. We don't always provide the PPFD map. Some utilities, Excel in Colorado comes to mind, where they ask you to submit the PPFD map. So obviously, we'll always do that when required. Otherwise, we usually just calculate it in the lighting software and then report on it in essentially our energy savings analysis. Next slide. So if you look at this, just sort of example, we'll say it was a flowering room based on what we had, based on the fixtures that were in there. So 12 hours a day, more or less running all year for annual hours of 4,380. Again, is 40 per tier, so 80 total in each room. And you're just kind of basically running through those numbers. And in a room of that size, you'd be looking at kWh savings of just shy of 160,000 there. And then just a few notes up top, again, just for people who aren't really familiar with the process, but the energy savings is obviously claimed by going above and beyond the baseline. In this case, we'd be looking at standard practice rather than code or regulation, which is the case in a few places, Massachusetts, Illinois, in another 2 years or so, California is likely to have some sort of code as well. Again, the actual incentive could be based off the kWh, kW, or some combination of the two. And then the first year savings are the only savings that are claimed. So if we move on to the next slide, I'll talk about sort of the 3 challenges that I've highlighted. And this is a really common one. As Jeannie alluded to earlier, particularly when you're talking about cannabis, but it's also applicable on the commercial agriculture side. Cannabis loves light. It can take a whole ton of light, and it's can be very difficult to get all the light that you want in there. So it's not uncommon that we find customers who have legacy technology, typically HPS, and we find that they're underlit. So if you move to the next slide, we have one kind of setup here where we've kind of modeled a PPF match again, or PPFD match. In this case, again, it's kind of one and the same only because the fixtures are so similar. I don't think it's any surprise. There's other manufacturers out there. A lot of people intentionally go and try and find that sort of one-to-one replacement for legacy technology. But if you do that, you'll notice we have the sort of colors over there. In this case, it's just a single tier, not multi-tier. But you'd have a PPFD average of, let's say, nominally 900 here. When you do that, look at the savings. I mean, you get great energy savings just by the fact that you're going from HID lighting to LED. But what happens if they say, well, 900 is all we could get right now. Really, we want to make a process change because we want to increase our yield or for whatever purpose. If you move on to the next slide, you can see what a wattage match looks like. And notably, they're obviously using the same amount of wattage, but look at that PPFD average. It went from the same at right around 900 all the way up to 1500, which at that point of certainly cannabis could take it, but you're also looking at other atmospheric conditions, CO2 supplementation and things like that. There's also other considerations, particularly HVAC was mentioned when you're talking about greatly reducing in that first and the last slide. If you're talking about greatly reducing the wattage of your room, you're also talking about reducing the heating. Then your HVAC might be turning on and off more because the system was built for more capacity there. So there's lots of things to consider. But one thing that you can do, and I've seen programs do, is they'll run it through basically a retrofit through the one-to-one. So if you look there, there's 72 HPS fixtures. They'll run it through retrofit for there, and then they'll do new construction for the remaining. So while it is a challenge, there certainly are ways to get around it, and that seems to just be kind of the common one that utilities have coalesced around. Next slide. I'll try and cruise through here these last few. Unclear baselines, super common issue. Next slide. I'll talk about intercanopy lighting, which is a commercial agriculture play. In this case, anything with a vine crop. You can see we've got, I think, tomatoes in both pictures there. For those not familiar with the technology, it's lighting that literally goes right through the crop as opposed to top lighting. So next slide. This one's almost impossible to baseline because there's no legacy technology that gets used physically intercanopy. The true industry standard would be comparing it to top lighting. And so we ran across a scenario where we were kind of not satisfied with what the utility or what the implementer chose. So we went back and modeled a couple of different baselines. Next slide. You can see the different ones. We modeled a top lighting. The second one was basically a shielded fluorescent. It's basically a one lamp fluorescent luminaire strung, one by one along. And then the third one is unshielded. So basically just bare lamp fluorescence. We said straight off the bat, number 2 and number 3 are not real things. They do not exist in real life. There are no known commercial installations of this. But the big impact you'll see on the next slide, which is depending on what you chose, the amount of savings you're claiming could vary greatly. So if you go with top lighting, the true industry standard, you're looking at about 1.3 million kilowatt hours. But if you go with that bottom one, you could be looking as little as 400,000 or a little bit greater. So I'm not sure I have a clear solution for this one. It's just tough, and utilities really just have to lean on subject matter experts or others that can kind of help them guide that baseline. Next slide, which is again, just horticultural lighting changes are really process changes. It's not the same as an equipment change. If you're installing a 2x4 troffer in an office space moving from fluorescent to LED, it's not a whole big adjustment period there. But you walk into the office, is the light on? Yep, it's on. Okay, great. But when you're talking about growing plants, it's entirely different. So next slide. Both of those previous examples I gave are pretty good sort of case studies as to what those process changes mean. And then another one down there is another customer I've worked with recently discovered that basically increasing the photo period and in their crop was okay. They thought they needed X amount of hours for the plant to rest from light. They determined they didn't actually need that. They could increase the photo period, which would increase yield. So again, lots to consider, and it all really starts at grower preference. And then last slide is the call to action. So for manufacturers, please get out there and participate in industry dialogue about whether it be code, standards, regulations, whatever. I often find that I'm one of the only out there certainly talking about it a lot, so certainly welcome more industry colleagues. And when possible, be an unbiased subject matter expert for utilities. They're learning a lot too, and the last thing they need is a sales pitch. Growers, reach out proactively to your utility. You need them in your corner. You want them in your corner, not just for incentives, but also power hookups, things like that. Utilities, echoing the same thing Bob said, make yourselves visible and welcoming. If you're a utility and you do not have a landing page for growers, go out and request one. That is the absolute best thing I could say for you all to do as sort of an immediate action. And then don't forget non-commercial growers as well. Obviously DLC is focused in that space, but residential growers, there's quite a bit of load there, and there's new programs popping up around that as well. So that is all I have. Sorry, I'm just a few minutes over there, but look forward to the Q&A.
All right, thanks, Brady. Thanks, Jeannie, Bob, and Mike as well. Yeah, a lot of good questions coming in, so let me jump right into them. Mike, maybe this first one you can take first crack at, but obviously all our panelists can chime in. Can you talk a bit more about the limits to watts per square foot in terms of non-cannabis crops. It seemed that would be a valid benchmark for many, most or all food and flowering crops. You know, and is there a difference with greenhouse versus indoor ag when we talk about that?
In terms of the limits, well, there aren't any, you mean, is the question in terms of regulation?
Good.
Because there aren't any regulations for vegetable crops that I'm aware of. You can essentially do whatever you want. No one, but for the most part, those vegetable crops require a far lower amount of light than cannabis, which is one of the reasons that this, you know, it hasn't come up over there in that space as quickly as cannabis has, especially since cannabis requires so much power and is being built out so rapidly.
Okay, thanks. Jeannie or Brady or Bob, any additional comments on that one?
Yeah, I'll chime in that I think, like it's been mentioned otherwise, the energy codes to date haven't addressed horticulture lighting because it is a manufacturing input, and I think that's an appropriate designation. And there are some states that have used the power of energy codes, and they really just applied that to cannabis growers, which is just kind of messing with their business models and having them, you know, shift expense and build facilities differently. So as far as baseline wattage for, you know, greenhouses or non-cannabis facilities, well, I guess I don't know where the rest of that thought is. It's definitely lower than cannabis, but you just kind of reverse engineer it from, you know, what's the PPFD you're installing, you know, divide it by the fixtures.
Was the original question about was lighting power density? Did I hear that as how that affects, or?
Yeah, it was more about the limits to watts per square foot.
Yeah, I think I won't speak for the others. I think Bob and I are certainly in alignment. I'm not a big fan of lighting power density for any horticultural space. It just doesn't align. You're looking at having to create a different lighting power density for every different crop, or indoor sole source versus greenhouse. To me, it makes absolutely no sense. I accept that there are states that have gone down that path. But if I can get on the soapbox for 10 seconds, I'll just say that I hope other states don't look simply to Massachusetts, Illinois, say, hey, it's already been implemented. I don't really know much about it, but it seems like it works, so I'm going to follow that model. I would certainly hope they do not follow that model. There's been lots and lots of difficulty in implementing that. So I would stay away from lighting power density.
Agreed.
Yeah, so you two are really focused on PPE as the focus area.
Yeah, I think the efficiency of the product.
I think that's what probably makes the most sense. Yeah.
Yep. Okay. Thanks. Okay. Next question here, and you know, maybe Jeannie or Bob might be good for answering this one initially. Are any utilities looking at incentives for control and sensor technologies, or is focus primarily on light?
I can take that. I think we're looking at that as a custom project right now in terms of a greenhouse. Well, what is the baseline? So it's something I'm working on in my work now. I don't think it's 100% established, and I think there are some really advanced control technologies out there that are helping. You can have threshold control that's going to turn off the lights when the cloud goes over, or turn on the lights when clouds go over and turn them back off when the sun's out in a greenhouse. So I think there's a lot of opportunity for that. I don't see that being necessarily a prescriptive type approach, but certainly as a custom approach, even though I say it's a lot of burden on the customer, it tends to be more lucrative for the customer as well. So I do think there's potential there.
Yeah, I was going to say, I think controls, as far as incentives go, are really relevant only in greenhouses to respond to what's happening with the sun. And LEDs have the ability to dim on and off much more quickly than, say, HID technology that has a warm-up period. So the controls can just manipulate those hours of operation much more dynamically. And yeah, there's incentive dollars for that. All custom, of course.
Yeah, no, thanks. Yeah, because it's definitely everything has to be taken into account when you're tying together, looking at the incentives. So Bob, you had brought up about calculating HVAC savings. So there were some questions about how do you calculate HVAC savings and what are some of the factors?
Sure. I think the easiest way to do it is to look at the efficiency of the air conditioning equipment, the EER, right? And based on that, I mean, we know that every watt introduced into a space needs to be cooled. That's a input assumption. So every watt is 3 BTUs that need to be removed. So if you look at, if a 12 SEER is, I don't want to say the wrong thing. I'm going to say the wrong thing. I have a little table that just has the SEER values and how many kilowatts required to remove 1,000 BTUs, for example. You'll just get a little bar chart showing that the higher the efficiency, the less the air conditioning savings are because it cools it more efficiently. But you get a range of 25 to 40% savings incremental to the actual wattage reduction or kilowatt hours reduced from the lights. I'm happy to share the arithmetic with anyone. It's fairly straightforward math. There's a constant based on the SEER value, how many watts required.
No, thanks, Bob.
Mm-hmm.
Mike, when you're doing your design work, how do you take into account HVAC implications?
Yeah, it's I smile because I got into this as an electronics engineer, really focused, and I thought lighting was going to be my focus, and it was for a while, but it really has turned into focusing on HVAC because this is all one big system. So one thing, how do I take into account? I think one thing that's important to note is that, okay, so in a cannabis grow room and in most indoor ag, there's cooling from the lights as one process, and then dehumidification of removing all that water vapor that goes in that room. If you water 100 gallons into a sealed room, 100 gallons of water is going to have to come out of there too, and that ends up being a primary energy driver. So what happens is you take all of that heat out of the room because of you're removing those HID lights. But there's still the same amount of plants and the same amount of water vapor coming up. So the sensible heat ratio in the room goes down. So you actually have to account for a lot. You have to account for that loss of heat energy in calculating how much additional heat you're going to need, whether it be from electric chilled water, some other from other source, or water heater, some other source to reheat air as it goes into the space. That HVAC is for these rooms is quite complex and a whole other rabbit hole.
Yeah, like you said, you started with lighting and it evolved into a whole lot more when you start looking at the entire facility, and then that's always going to happen. It's the interaction of all the systems together. Let's see here. I think there was a little follow-up maybe along that line when we were talking about the HVAC, because it looks like it was, how about BTU comparisons between models for HVAC savings? So is that a good way of looking at it as well?
If you're,
Go ahead, Mike.
is that to me?
Yeah, either way. Sorry, Mike or Bob.
I think, I don't know how to, that's a tough one because you have all the extra energy that you need to put into dehumidification. I defer to Bob on that as he's probably gone through that calculation, getting that rebate before.
I'm not sure I really understand the question.
Well, yeah, so I think it was coming off of when we were talking about SEER and how to look at the savings and that's what I'm assuming this was, because when it said, how about BTU comparisons between models for HVAC savings? So I'm not sure. Yeah, go ahead.
I mean, the higher the SEER or the EER of a cooling equipment, the fewer watts will be required to remove those BTUs. So that's why higher SEER equipment has a smaller HVAC interactivity. Whereas a SEER 10, something kind of low, maybe industry standard, the savings could be more like 40%. You save 1 million kilowatt hours from lighting, and it's another 400,000 from the BTU removal.
Okay, I got the clarification here now.
Okay,
Sorry, thanks, Charles. Yeah, so you know how lighting energy can be converted to BTUs. So can that be part of the comparison when you're modeling the HVAC savings to take into account the total energy used by that facility?
That's the driver of the calculation. If we have 1,000 watts, that's 3,400 BTUs that have to be removed. So that is driving that.
Yep. Okay.
I see someone.
Yeah. So thanks for that clarification.
Yeah.
So Jeannie, maybe you can take first stab at this one. Which is more common baseline? Is it dimmable HPS or on-off HPS?
So the approach we've taken with that depends on the control technology that's installed in the efficient system. So if the grower is opting to do dimmable LEDs, the baseline would be a dimmable high pressure sodium, depending on the stage of growth, but with limits on how you could dim that technology, given that most high intensity discharge lighting isn't going to be able to be dimmed below a certain threshold. So we set that limit there, but that's how we've handled that.
Yeah, so you're really looking at what that existing is and what they also want to do in that facility and working with them in a custom manner.
Correct. It's based on their operational strategy.
Yeah. Okay, good. Does anyone know of a good calculator for energy savings? So maybe someone that can, they want to do their own little thing just to kind of get an idea of what's going on, before really going down some of these paths.
I mean, I use Excel. It's, yeah, I don't know if there's no I think eQuest or any of those things. I mean, they could be useful if you're doing a full facility model. That's above my head. But I just use straight Excel, and like I say, for me, I model it based on PPF or the PPFD, same thing, just spread over in a certain area, and that'll give you your delta wattage, and then you just extrapolate to whatever you need.
Yeah, I agree. You don't need anything fancy by any stretch. I would say, sit down, take 30 minutes, just build your own little calculator. I mean, oftentimes when I'm walking into a new project, if it has certain rules, I've tried to build one sort of catch-all calculator, but I've realized that so many since everything's custom for incentives anyways, you might not need one set of factors for one program, you need them in another. So trying to build one catch-all isn't necessary. So half the time I find myself cracking open a brand new Excel, typing in about 10 boxes, and I have my back of the napkin math that I need to estimate and whatnot.
I guess if anyone's looking for something, feel free to email me. I'll share some Excel templates for different use cases. I'm happy to share. It's not proprietary.
All right. Yeah. No. Thanks. Thanks for setting that offer up there, Bob. Brady, this one was specific to you during your presentation. In your discussion about inflated intercanopy projected baseline, what's the estimated cost to add the unshielded fluorescent lamps? And this would be to determine the incremental cost.
Yeah, I think I saw that one come through. So I should clarify that inflated one, again, those are pretty complicated projects that have literally months of back and forth. I tried to distill down into about a minute or so. The reason it was inflated, that was actually the original baseline that they had chosen. And they kind of have this artificially high PPE requirement on a fluorescent lamp, more than anything that I know of actually exists in the market. And so that's what I meant by inflated there. So I don't know if that clarifies the second part of your question, but on each of those, we just went through and did an incremental cost. So we found, obviously, since I was pulling something out of fiction, I just based the price on whatever actual T5s in the case we're going for.
Okay, thanks.
Hopefully that's clear. If not, I can follow up after.
And Jeannie, there was a request if it can be made available, a copy of the new construction cannabis lighting.
Yeah, I am able to share that. If the requester could just send me a message, I like to keep track because I am working on version 2.0. There's, maybe a mistake or two in one of the formulas that I want to fix before I would resend that out. So I'm trying to keep a list of anybody that has it.
So Jeannie, just if you can say your email address one more time, because you're spelling your name is on everything.
Yeah, so it's a long one. JEANNIE.Sikora, SIKORA. I could put it in the chat at clearresult.com. And
Yeah, that probably work. Yeah.
Yeah, that would have been better. All one word, single R, not plural.
Okay. So we had a question about, I know we really didn't talk about it here, but since we have a little bit of time, I'll throw it out there. Maybe Mike, you can start off. Any experience with liquid cooled lighting? You're on mute, Mike, sorry.
Thank you. Sorry about that. Yeah, I've done a custom both off, have some experience both off the shelf and built liquid cool lighting solutions for people where they had a really special high density situation. In the standard grow rooms that I have encountered, a lot of times I end up wanting to reroute that. You need to reroute that heat that you're getting off the lamps back. You want to recover it back in for your dehumidification reheat process. They're great. It just ends up, you end up having to, if you just get rid of that heat, you end up needing usually to bring heat back into the room for dehumidification. But they work great. You can put down a lot more, light from one singular fixture if you have the ceiling height to be able to get high over the canopy of the plant.
Okay. And any other panelists want to comment on that?
Well, I've processed a couple lighting projects for liquid cooled fixtures, and the lighting part of the analysis is the same. It's just a more efficient way of moving the heat away from the plants. But then it becomes a question of what do you do with that waste heat? And sometimes it's just expelled to the outside anyways. So you're saving, it's not like that heat disappears. It still needs to be mechanically cooled and expelled. But if they do something interesting with it, I've always been looking for that project who would co-locate with like a car wash or something, use all that waste heat for something great. That would be very cool. Haven't found that yet. But yeah, the utilities have given some separate incentives for the dry coolers. And those savings can be significant, but that was unfortunately, the lighting programs are often separate from the HVAC programs. Even though I've been talking about interactive savings and getting credit for those on the lighting side, the HVAC team analyzed those and gave some incentives separately for at least one project that comes to mind.
And Jeannie, have you been approached at all to create any program work around liquid cooled lighting?
I have not, I don't have any experience with liquid cooled lighting.
Okay, yeah, I didn't know if Mike or Bob were knocking on your door yet for incentives.
No, we have looked at some advanced dehumidification technologies and done some measurement and verification there, but not with liquid cooled.
Okay, thanks. Let's see. I'm not sure I'm quite understanding this question. Is there an 8760 hour per year, so 7 days a week, 24 hours a day, 365 day a year model to account for periods where heat is beneficial, outdoor air has higher, lower relative humidity, etc.? I think that message might have come, Kip, I think you might have sent that. So if you want to pull yourself off mute maybe and clarify that for the panelists, if that'll help.
I'll just point out that we that's a whole separate other, when you start talking heat or other stuff, that's a whole other separate conversation. So while everyone here might touch on it in some manner, tangentially, Mike probably touches on it the most in his work, but they're basically whole experts on that side of the equation. So it's a good question, but I think it might be best suited for others.
Yeah, my simplified assumption is that you're always cooling in an indoor facility 100% of the time, coincident with lighting, and that we're not bringing in outside air because no one wants it, and we're often fighting economizer regulations. Growers don't want to introduce outside pests and mildews. They will add economizers to pass code and then literally block it off and condemn the equipment the next day. So there's certainly the outside temperature might affect the cooling loads in general, but Mike definitely is speaking about the reheat for dehumidification. That's above my pay grade.
So indoor rooms are usually built, as Bob alluded to, we do not want outside, so it's full recirc because it's we're boosting the CO2 level, so we don't want to, which has a cost associated, we don't want to exhaust that out. So it's better just to go full recirculation. Also, from a biosecurity standpoint too, even if there is a moderate amount of savings available from using an economizer, it's not worth the biosecurity risk to the crop to bring in outside air. There are models to account for this in greenhouses. Based on what climate zone you're in, how much solar radiation you get will determine how much supplemental light in the rest of your system. But for indoor ag, the location doesn't matter. We don't factor in the climate zone or the outside air. It's inside its own insulated box.
This is Kip. If you can hear me, I think I'm unmuted. Yeah. And I was just going to say, thanks for the chat. I do think that part of this is the fact that it's such a broad spectrum of operations we're talking about. So I mean, my question was more geared around this idea of if you're really trying to get a relatively accurate savings estimate, then you should be thinking about those interactions. But I was also thinking more about greenhouse operations as opposed to indoor ag, and so. I mean, I guess that's part of the overall message is there's so much complexity in what's going on in all these different operations that it's kind of hard to drive towards a simple solution. And I think, and that's also the root of my other questions, is kind of like trying to figure out how do you really build a simple prescriptive methodology if you're trying to account for all of these different uses of this equipment, both the lighting equipment, the effect on the HVAC. So anyway, I appreciate all the conversation and discussion. It's useful.
His last point is actually a great point, and I would advocate personally not trying for us as an industry to not try and capture every last bit of energy savings that we can, because the strain that puts on down the line is pretty great, whether it's on manufacturer in our case, or the people like Bob doing on behalf of manufacturers, or the customer themselves. There's just so much more deep diving that has to occur. These facilities are going up now. I think that it's best to go for the low-hanging fruit, claim as much as we can right now, get incentives for what we can right now, not search for the perfect. But I 100% agree that there's a lot that could be studied about the energy savings here. And unfortunately, it's another downside of federal prohibition, at least on cannabis, is that this is a huge market. There's lots to be studied on it, but lots of money can't go towards studying it because of the illegality of it. So I would certainly love to have that full picture, but I would also much rather shoot for the low-hanging fruit now.
And I'd agree with, I'd like to add to that, I guess, just, there are some places where the discrepancy between these low-hanging fruit type of easy rebates and the ones that are a little bit harder to get to is huge. So For an example, there's an incentive program where the prescriptive incentive is 5 cents a kilowatt hour saved. The custom is 22 cents a kilowatt hour saved. So this HVAC project I'm working on, indoor ag, we're looking at close to 40% of the cost of this advanced HVAC equipment is being paid for by the utility. So in some places, I think it makes a lot of sense to go in that deeper dive and really go to the work to get there. So, but horticultural lighting sure is an easier one, and very, very saves a lot of energy in these facilities.
Yeah, thanks, Jeannie. Appreciate that last input there, because we are at time to wrap up our Q&A right now.